In our next example, we are going to use back substitution. So the recurrence relation is T1 is equal to 1 and Tn is equal to 2 Tn over 2 plus 2. The steps that we need to do for back substitution, like before, for a draft, we need to find some values of Tn. Since we are going to do back substitution, if Tn is given as 2 Tn over 2 plus 2. So what will be the value of Tn over 2 equal to? If you substitute n over 2, n here, so you will have n over 2, if you substitute n over 2 in a place of n here, then you will have n over 2 over 2, so it will be n over 2 square. So this will be equal to t n over 2 square plus 2. Now if you want to find t n over 2 square, then this will be equal to t. Now if you substitute this value n here, so it will be n over 2 square divided by 2. So it will be n over 2 raised to power 3 plus 2. If we continue this, then we need to do the substitution for these terms and the original recurrence relation. Our original recurrence relation is now the solution. Okay, I need to write here a solution because we are still in the draft area. So here is the solution. We will start Tn is equal to 2 Tn over 2 plus 2. Now we need to substitute for the value of Tn over 2, and it will be equal and multiplied by 2. So we need to multiply this equation because it is Tn over 2. We multiply it by 2 and the answer will be equal to 2 square Tn over 2 square plus 2 square plus 2 from the previous step. And for the next, we need to multiply the equation for Tn over 2 square, which is this one, by 2 square. So we will get 2 to the power 3 t n over 2 to the power 3 plus 2 to the power 3 plus 2 square plus 2. So basically we are multiplying the previous step by 2 by 2. So if you want to get the next one, then multiply this equation by 2. So it will be 2 to the power 4 t n over 2 to the power 4 plus 2 to the power 4 plus 2 to the power 3 plus 2 square, and don't forget you already have 2, okay, in that step. We can now label the steps. We can say that if this step is here, if this is a step 1, this is a step 2, this is a step 3, and this is a step number 4. Then what will be the equation at step number k? This is step k. What we will have? We will have 2. This is a step 4. So we will have 2 to the power k t n over 2 to the power k plus we will have a summation. I will label the index for the summation j, and it will be 2, and if I go from right to left, it will be raised to power j, and j starts from 1 up to k. Because if this is a step 4, so we go from 1 up to 4. So if we have a step k, it will go from 1 to k. This is a geometric sequence, and you know, for geometric sequence we prefer that the indices start from 0. So we need to change the sequence so that it starts from 0. This summation can be rewritten as summation j starts from 0, 2 to the power j plus 1, and it goes up to k minus 1. How did we find it? For the first value of 2, when j is equal to 1, it will be 2 to the power 1. And the second, it will be 2 to the power 2 until k. If I want to make the summation on the right hand side, if j starts from 1, make the first value 2, then I have to add to the power 1. So if j is 0, then we will have 0 plus 1, which is 1, and etc. To get to the final or the final value of the index, we have j plus 1 is equal to k. So j is equal to k minus 1, and this is why we substitute k minus 1 for j. And this is, I'm going to rewrite it. So this is going to be 2 to the power k Tn over 2k plus 2 multiplied by j is equal to 0, k minus 1, 2 to the power j. From where did we get this 2? Because this is 2 to the power j plus 1. So this will be 2. This part is equal to 2 times 2 to the power j. And 2 can be taken outside from the summation. Finding a closed form for this equation. So this is 2k Tn over 2k plus 2 times 2 to the power k minus 1 over 2 minus 1, which is 1. And this is equal 2 to the power k Tn over 2k plus 2 multiplied by 2k minus 1. Let's leave it like that. At the end, eventually, at the end, Tn over 2k will reach the initial value. So eventually, this value will keep decreasing until it reaches the initial value. So the parameters inside should be equal. So we will have n over 2 to the power k is equal to 1, and we will have n is equal to the power k. If we take log both sides of base 2, then this will be log 2n. If you remember the solution for forward chaining, at the beginning we assumed that n was 2 to the power k. But for back substitution, we shouldn't do that. It will come automatically by itself when we do back substitution, and see what we have found, that n is a power of 2. Substitute, since n, see in here, since n is equal to 2 to the power k, so substitute into this equation, the last equation we have obtained. So this will be equal to Tn is equal to 2 to the power k is already, 2 to the power k is already n. So we will substitute n multiplied by T1, because this value is going to reach T1, plus 2 multiplied by n minus 1, because 2 to the power k is equal to n. After we do little simplification, because T1 is 1, then we will have 3n minus 2, and this is the last solution.